Introduction to Containers. A container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. Containerized software will always run the same, regardless of the infrastructure it is deployed on. Containers isolate software from its environment and ensure that it works uniformly by separating application dependencies from infrastructure. A container image is a lightweight, standalone executable package of software that includes everything needed to run in an application: code, runtime, system tools, system libraries, and settings. Multiple containers can run on the same machine and share the OS kernel with other containers, each running as isolated processes in user space. Containers take up less space than VMs, can handle more applications, and require fewer VMs and operating systems. Introduction to Docker. Docker is an open source project for automating the deployment of applications as portable, self-sufficient containers that can run on the cloud or on-premises. Docker as a software platform allows you to build, test, and deploy applications quickly. Docker packages software into standardized units called containers that have everything the software needs. Using Docker, you can quickly deploy and scale applications into any environment and know the code will run. More information about the project you can find behind the link that is given here. Let's have a look at some basic Docker commands. With Docker PS, you can list the running containers. Or with the -a extension, you can show all the running and exited containers. With Docker run, you can create a container from an image. Docker stop will stop a running container. Docker kill kills the container by stopping its execution immediately. The difference between Docker kill and Docker stop is that Docker stop gives the container time to shut down gracefully, while Docker kill terminates the container instantly. Docker exec command gives you access to the running container. Docker images lists all the locally stored Docker images. Docker rm deletes a stopped container. Docker container log shows the logs of a container. And with Docker -- version, you can display the currently installed version of Docker. This slide shows an example output of the Docker ps command displaying all containers currently running in the Sonic system. We can see 20 containers which form a base of the networking operating system and provide all of the features available in Sonic. The Docker ps command shows details such as container ID, which is handy for performing operations on a single container, image name, and version of each container, along with the command which was used to start it, creation date, current status, and the short name of the container. When an end user decides to run additional containers within Sonic, for example to add a new feature, they will also be displayed here, with a custom name chosen by the container's developer. How does Sonic use containers? Sonic utilizes Docker and container technology to provide modular system architecture and separation of all system functions. Each system or network feature provided by Sonic is delivered by a separate container. We will discuss this in more detail in the system architecture lesson.